Hello, Algebra 3 students. Today we are going to move on to 5.2 and we are going to dig into the properties of exponents and the property of radicals. This is the first of several lessons on this topic, so very important to get the fundamentals. We're going to start with a quick review of the properties of exponents that you have studied previously in algebra and even in Algebra 2. The product of powers. So if we have two powers with the same base, notice the bases both have to be a. If we want to combine these two, a to the m times a to the nth, if the bases are the same, once again, then we can combine them and it's going to be a to the m plus n. So a product of powers means you add the exponents. I have some examples over on the right that you can always come back to. We'll go through some more examples down below. When you have a quotient, so the first one's a product, the next one's a quotient. Again, those bases are the same. If the bases are the same, we can combine them. It's going to be a to the m minus n. We subtract the exponents in a quotient. Power of a power. Notice we have an exponent, then we raise it to a second exponent. Power over power means we are going to multiply. Again, we are going to multiply the m times the n. Power of a product, we can distribute that exponent and it becomes a to the m, b to the m. And finally, a negative exponent. Again, notice the negative is on the exponent only. We take the reciprocal, or 1 over a to the m. We're going to use these rules to simplify expressions. All right, here we go. Starting out with letter A, notice in this problem, we have two bases that are the same. We have 81 as a base and 81 as another base. If we want to combine those into a single base, we can do that. Our rule, our property is that we add the exponents. So this will be 81 to the 5/6. If I get a common denominator, that's negative 2/6. When we add those together, 81 to the 3/6. We know 3/6 is 1/2. We know that 1/2 means square root. The square root of 81, the answer would be 9. All right, letter B. All right, we have a few things going on here. The first thing we're going to do is take the numerator to the 2/3 power and take the denominator to the 2/3 power. Right, we're going to remove those parentheses. When we do that, we're going to have x to the 2/3 in the numerator. We're going to have a y to the 3 times 2/3. We have a power, the 3 raised to another power, the 2/3. We multiply. Sorry, that's a 2/3. Then we're going to divide that by x to the 1/2. That's also raised to the 2/3 power. So we're going to multiply that. 1/2 to the 2/3. We multiply the 1/2 and the 2/3. Now, simplifying that, the numerator stays x to the 2/3 times y. Now, when I multiply those together, 3 times 2/3 is just 2. So y squared. In the denominator, I multiply those together, and I'm getting x to the 2/6. All right, now x to the 2/6 is the same as x to the 1/3. Finally, I am dividing two terms, the x to the 2/3 and the x to the 1/3. I have a quotient, and the rule means, or the rule talks about, if I want to combine those, I can subtract the exponents. So in that case, I'm going to have x to the 2/3 minus 1/3 times the y squared stays y squared, which means my final answer is x to the 1/3 y squared. All right, example C. Again, we have this 1/2 power. That is going to be distributed to the numerator and denominator. So I'm going to have 3 to the 1/2 power divided by 32. Now, power to a power, we are going to multiply the 2/5 times 1/2. I'm going to have 3 to the 1/2 over 32 to the 2/10. That's going to be, now I'm going to write the square root of 3 for 3 to the 1/2 over 32 to the 1/5. That's the square root of 3. 1/5 is the 5th root of 32, which we know is 2. So this ends up being square root of 3 over 2. All right, I'm actually going to go back up and rewrite this final answer. We are going to write that as the x to the 1/3. Okay, I'm going to actually write that as the cube root of x times y squared. All right, back to letter D. Again, we have a power outside of parentheses, so we are going to distribute that 2/3 to the AB to the 1/2. And again, for now, I'm going to leave the 2A 1/3. When I distribute, I will get this A is a 1, A to the 1st times 2/3. It's going to be A to the 2/3. When I distribute the B, remember, 1/2 raised to the 2/3, power to a power, you have to multiply. So right now, 2A to the 1/3, A to the 2/3. When I multiply here, I'm getting B to the 1/3. Not finished yet. We can combine because we are multiplying. When we are multiplying and have terms that have the same base, they can be combined. Remember, we add the exponents in this case. When you have two powers with the same base, we are going to add the exponents. So this will become 2. Now those A's can be brought together. Those A's can be brought together if you add the exponents, and the B remains B to the 1/3. When I add 1/3 and 2/3, I get 3/3. So my final answer, A to the 3/3 is 1, so 2A to the 1st, 1/3 is a cube root. So I'm going to multiply that times the cube root of B, B to the 1/3. All right, something to point out in those problems that say use properties of exponents. Our answers, if possible, were all written with radicals. The original problems did not have radicals, but when we use properties of exponents, we can rewrite them with radicals. Okay? Now, the reason I point that out is our next set of problems, we're going to now start with radical symbols, and we're going to use the properties of exponents to try to simplify, as you can see in the directions, simplify and write our answers without radicals. Write our answers without radicals. All right, again, we're going to split this up Cube root of 16. Cube root of x to the 5th. Okay? I'm going to try to do this two ways, but bear with me. So 16 does not have a cube root, so I'm going to break it down. I know 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So 16 is the equivalent of 2 to the 4th. X to the 5th, the cube root of x to the 5th, I'm going to write out that x to the 5th, 5x's multiplied together. Now, we learned in yesterday's lesson that when we take the cube root, for every group of 3 2's, we can pull one out. Now, which means there's going to be one left over, right? For this group of 3 2's, because we have a cube root, I can take out 1 2, but that is going to leave me with a cube root of 2. That fourth 2 is going to be left over. Now, over here in the next cube root, again, I have a cube root. When I look at x to the 5th, I have one group of 3, 1x cubed. So when you take the cube root of x cubed, you can take out 1x. However, notice I have 2 left. So I still have inside the cube root x squared. I simplified each piece. Now these are multiplied together. As a rule, the coefficients, the numbers in front of the radicals, can be multiplied together, so 2x. And we can multiply, as long as the roots are the same, we can multiply what's underneath together. So I have a 2x on the outside, right there, and then simplified to a 2x squared on the interior of the radical. All right, now just going back to yesterday, another way to think about this cube root of x to the 5th. All right, we can rewrite that as x, the power is 5, the root is 3. Normally, on the problems yesterday that we worked on, we would take the 5 and divide it by the 3, and it came out evenly. Now it doesn't, which means there's going to be a remainder. There's going to be some left over in the cube root. So if I'm going to do this problem, I think about how many times does the 3 go into 5, right? And that's once. So I can pull out an x to the 1st. It also tells me that there's 2 left. So I have 2/3 left. So I have the cube root of x squared left over. 5 divided by 3 is 1, right? So I have x to the 1st when you divide, and there's 2 left over. So I have x squared left over under the cube root. Okay. All right, moving over to example B. Now, here we go. 4th root. So we're going to make this the 4th root of 81. We're going to take the 4th root of a to the 8th. We're going to take the 4th root of b to the 5th. Again, here we go. The 4th root of 81. Not sure, but I think 81 is 3 times 27. 27 is 3 times 9. 9 is 3 times 3. That leaves me with a group of 4 3s. Because I'm doing the 4th root, That part of my answer is going to be just 3. The fourth root of 81 is just 3. Now, part 2. Here I can rewrite this as a to the power, which is 8, over the root 4. That really leaves me with an a squared. 8 divided by 4 is 2. So the second part of my answer is a squared. Finally, here we go. Now I have, if I rewrite this, I have b to the 5/4 4. If I divide these two now, 5 divided by 4 is going to give me b to the 1st, but under the fourth root, I still have some left over. There's going to be 1b left over, so I have the fourth root of b. When I put this all together, I'm going to have 3a squared b, fourth root of b. Now, I want to point one thing out. Another way to think about this fourth root of b to the 5th is the fourth root of b times b times b times b times b, 5 b's. And remember, when we have a fourth root, for every group of 4 b's, I can take 1 b out, and guess what's left over? I still have 1 b under the fourth root, which is exactly what we get for our answer. All right, just got to go back a little bit. Alert, alert, alert. My mistake here. Your answers can and will have radicals in them here. We are just simplifying them. So that was a mistake earlier in my video. Make sure you make note of that. All right, here we go. Now we have a cube root. So I'm going to rewrite this with parentheses because that fraction is going to be to the 1/3 power. We have an x to the 4th and a y squared, a 1/25th x. Now, it becomes important sometimes to make these problems easier. Mathematics has an order of operations. So if we can simplify inside of the parentheses first, sometimes our problem can be easier. I can simplify x to the 4th divided by x. We have a rule that when you divide powers, you can subtract the exponents. So in the parentheses, I actually have 1 over 125, the x to the 4th over x. 4 minus 1 is x to the 3rd, and then I still have a y squared to the 1/3 power. Now I'm going to distribute that 1/3. I'm going to have 1 over 125 to the 1/3. I'm going to have x to the 3rd to the 1/3. And I'm going to have y squared to the 1/3. 1/3 is a cube root. So the cube root of 1 over 125, the cube root of, when I simplify that, I can multiply these together. So I just have an x to the 1st. And here, I can multiply those together and get y to the 2/3. Now the cube root of 125 is just 1/5. X to the 1st is x. Y to the 2/3 just becomes the cube root of y squared. All right, in the middle here, we'll see some properties that we've already talked about, that if you have the nth root of a times b, you can split that apart. You can also take an exponent and distribute it to each term inside the parentheses. So the nth root of a product is the product of the nth root of the factors. And the same is true with a quotient. The nth root of a quotient can be split apart, the nth root of the numerator and the nth root of the denominator. All right, let's put these into practice. So notice here, what's important in letter A is that the roots are the same. So by rule, I can combine those, the fifth root of 16 times 8. Now, a lot of people may multiply that together, and you can still get to the answer, but what I would do is, because I have a fifth root, I can think of the 16 as 2 to the fourth, and the 8, so the 16th is 2 to the fourth, and the 8 is 2 cubed. So now, as I'm simplifying a fifth root, I look for a group of 5 2s. There's a group of 5, and I have 2 left over. So for every group of 5 2s, the fifth root of 2 to the fifth, I'm going to be able to take out a 2, but that's going to leave me with 2 squared left over, 2 times 2. So this ends up being 2 fifth root of 4 for that example. All right, over here, notice we cannot put these together in example B right away. We do not have the same root. So I'm going to try to work with them individually to see what we can do. So this 8x is the sixth root. So I'm going to call that 1/6 power. And this 2x is to the 1/3 power. Cube root. Now, I can rewrite the 8 as 2 cubed, x to the 1/6. Now, if I distribute my powers into the parentheses, to get rid of the parentheses, we are going to have a power to a power. So I'm going to start here. 2 to the third to the 1/6. X to the 1/6. 2 to the 1/3. And x to the 1/3. Now, if I take this a step further, I have a power to a power there, which means I can multiply the 3 times the 1/6 and get 2 to the 1/2, x to the 1/6, 2 to the 1/3, and x to the 1/3. Now we have some like bases here. When the bases are the same, the product of a power, right? We have a rule for that. I can combine those 2's because they're the same base by adding the exponents together. And I can combine the x's because they have the same base by adding those exponents together. Two to the 3/6 plus 2/6, and x to the 1/6 plus 2/6. So 2 to the 5/6, x to the 3/6. The sixth root of 2 to the 5th times x to the 1/2, which is square root of x. That's the best we can do. All right, then we're going to move to an important example, example C. This is going to bring us back to a technique which we're used to with radicals, And it's what we do when we have to rationalize. All right, so nothing can be simplified in the fraction. I cannot simplify there. So I'm going to make it the cube root of 2n over the cube root of 9m. My goal is to eliminate, when we rationalize, right, we want to eliminate the radical in the denominator. So if I want to eliminate a cube root, right, if I want to eliminate a cube root, the only way you can make that happen is if you do the cube root of 3 of the same things under the radical, right? That just turns into x. So if I'm going to eliminate this cube root of 9m, I'm going to need to have 2 more cube roots of 9m. So I'm going to multiply the top and bottom by 2 more cube roots of 9m. Now, what does that look like? Well, in the denominator, I'm going to have the cube root of 9m times 9m times 9m. And on top, it's going to be the cube root of 2n times 9m times 9m. Notice on the bottom, I have a group of 3 9m's, and I'm taking the cube root, which means the cube root cancels out, and I just have a 9m on the bottom. The radical is gone. On top, I'm just going to combine and rewrite 2 times 3 times 3 for the first 9 times 3 times 3 for the second 9, m squared n. Now again, if I want to simplify this, if I look at a cube root, whoops, sorry about that. If I look at this cube root, I have 3 3's right there. Right? For every group of 3, I can take 1 out. Cube root of 3 cubed. So I can take a 3 out on top. It's going to leave me with the cube root of 2 times 3, what's left. Right? Again, I have a 2 and a 3 left. So 6m squared n over 9m. And finally, 3 goes into 3 once, 3 goes into 9, 3 times. So the cube root of 6m squared n over 3m is my final answer. All right, finally, we are not going to do D. And just to work down to letter E, notice again that my roots are not the same. We have a 4th root and we have a square root. So we are going to work on these individually and see what we can come up with. I'm going to have the 27x squared to the 1/4, 4th root, times 3x to the 1/2. I'm going to distribute this 27 to the 1/4, x squared to the 1/4, 3 to the 1/2, x to the 1/2. So I distributed those powers on each term. Now, 27th does not have a 4th root, so 27 to the 1/4. However, here we have a power to a power, so we're going to multiply. 2 times 1/4 is 1/2. 3 cannot be simplified when it's to the 1/2 power, and I have x to the 1/2. So at this point, I have the 4th root of 27, square root of x, square root of 3, square root of x. Notice now I have 3 radicals that are the same, so I can combine them into 1 square root 3x times x, or x squared. Let's write it as x squared. And the square root, again, the square root of x squared simplifies. I can take out an x. So what I end up happening is I take that x out, and I still have the 3 there. Again, we cannot combine a 4th root and a square root. Therefore, we're going to see if we can rewrite this a little bit. So we have x. Now I really have the 4th root of 3 cubed. 27 is 3 cubed. Now, if I rewrite that, that's going to be x times 3 to the 3/4 power times 3 to the 1/2 power. Now, when I have the same bases, I can add the exponents together. That's going to give me x times 3. When I add 3/4 and 1/2, I get 5/4. That is going to be x times the 4th root of 3 to the 5th power. When I'm doing a 4th root of 3 to the 5th, 4 goes into 5 one time, so I'm going to be able to take out 1 3, and there's going to be a leftover of 1 3. In other words, again, remember, if you write it out, 3 to the 5th, for every group of 4, I can take out a 3, and there's a 3 left. So finally, 3x, 4th root of 3. Toughest problem of the day right there. Then you have a worksheet. Get some good practice. If there's questions, bring those tomorrow to class or flex time. Have a great day.